This is the nuclear facility after I have tightened up the nuclear waste reprocessing area just a little bit, not hideously, and hooked it all up and verified as much as I can without introducing any radioactivity that we're good. So, what was involved here? First off, well, let's look at one of these chains, and I will use that as the guide to show what's going on. So we have this line of reactors here. And we merge all of their outputs using the fastest belts we've got. So we move the radioactive waste, uranium waste, as quickly as possible onto the next stage. Here we have 3 lines. So we have the waste coming through here. These splitters arrange for 1/4 of them to go to the middle, as do these. So this belt carries 1/4 of the waste from 2 rows of the nuclear power plant. So 3/4 goes to here, 1/4 goes to there. The 3/4 go into this blender where we hit it with sulfuric acid and nitric acid and silica to turn it into non-fissile uranium. And when we're done, we have a output of water that we want to recycle. The recycled water is merged with the other half, so we're dealing with 1/3 of the factory here, 1/3 of the reactors. So same thing over here. And normally these would run at 240%, which would make this 90 and 60 and so on. I have cranked it up to 250 to provide just a little bit of excess capacity, so we will tend to stay ahead of the production of nuclear waste. The recycled water has a small buffer. I am anticipating that our production of recycled water may be slightly bursty, and we may or may not be able to send it to this reactor. This is a normal variable input priority system. Thank you, autosave, where recycled water is coming in on this pipe I've got highlighted, and fresh water is coming in from the top. So fresh water will only be brought into this if it's not full. So this system will tend to drain all of our recycled water before using any fresh water, we hope. It is very similar to systems I've put in place in the past. I have not tested this exact topology. All I can state for sure is that we do in fact have up to 600 cubic meters a minute of water coming in from the right if we need it. Now, if this doesn't work, then we can take all of the water from this and route it all the way down there and all the way out that way. We will look at the fluids over there last. Also, the input here of silica just comes from the main processing area. We had a belt that was directed this direction. So he comes out. If the belt is full, we sink it. Otherwise, we send it along. Before we activate this nuclear power plant, the sinks will generally go away. We're going to end up with sinks here for our plutonium rods, but the rest of them go away. So that gives us non-fissile uranium, and 1/4 of our uranium waste still exists. And we held that off to the side because the next step is to take uranium waste and non-fissile uranium and chunk them through the centrifuge for a bit, and out we get a plutonium pellet. And these are going to come out at 75 per minute. So a little faster than once per second, we're going to spit out pellets. And as quickly as possible, we encase those pellets in concrete, and that forms the encased plutonium cell. And the encased plutonium cell can be used together with control rods and beams and heat sinks to make a plutonium fuel rod. The plutonium fuel rods are going to come out at 0.625, so that's 5/8 of a fuel rod per minute. So 5 fuel rods per 8 minutes. And it's going to be 15 total because we've got, well, it's going to be 30 total because we've got 6 of them. And they get merged together and go into a sink. And I just dropped a sink in for each third rather than merging them all together so we don't end up with long runs of belts that are carrying highly radioactive junk that we are going to be tossing in our sink. So these guys require those 3 ingredients, which we have routed out here. The slowest producing one, I believe, is the control rod. We are using 3.75 of those per minute, so it's very slow. We don't need very many. So I've elected to bring this in as a vertically oriented bus. These are smart splitters that set these 6 up as a perfect manifold. In theory, our input should be much more, well, not much more, but our input should exceed what we need to process our waste. So the manifold can stay full once it starts full. I let this stabilize for a while. Our production of rods was slow enough that it did take quite a while to do. But as you can see, our manufacturers, all of them look like this, are already set to go with full loads of everything, ready to start taking encased plutonium cells and deal with them. So where do our inputs come from? Our belted inputs are easy. We already prepared them, and they just came in along these north-south lines here. And I, of course, have some smart splitters that are sending the overflow off to the sinks so that even though we are not cranking up the nuclear power plant, our production area is still being exercised. You'll see that there's an exception here for control rods. That's because the control rods are used in our waste production. They're also used in our fuel production. And if I was sinking the excess over there, it would be hard to make sure that the right number got sent that way. So what I've done is this splitter down here takes my control rods coming in, and it says, by preference, send all of them to the right until the right is full. So we want to keep the nuclear waste handling area absolutely filled up with control rods. So if it needs it, it gets it by priority. Any that it doesn't need, we're going to turn around and send to the materials for making nuclear fuel. Now, currently, all of these lines are getting as far as their overflow, so it sends them onward, and it sends overflow to sinks. So we can look here, and we can see what our production rates are for the various ingredients. And you'll see that some of these are really slow, to the point where I am not absolutely sure that they're all working. Let's sit here and watch for a bit. Let's see if these right 3 all get, oh, there's the control rods. And there's the crystal oscillators. So there's one more belt in here. I haven't seen anybody coming across the one in the middle. This guy right here, which is this guy right here, which is coming from this direction, which is coming up here, which is coming from down below. I don't see his inputs moving because I don't see any input here. This may be stalled. This is our production of beacons, and it is stalled because it is not getting any beams. Oh, there's some beams. We're getting beams coming in, and none of them are being sent to us. Well, that's because we are prioritizing to the right, and we're only sending the overflow to the left. Why are we prioritizing our beams to the right? So we are prioritizing our beams to go out to the nuclear waste area, which is sinking the excess and causing us to not get anywhere else. So I'm going to do the same thing here that I did for the control rods. I'm going to not sink the excess here. Now, if I do this, if I don't sink the excess beams, that means that we will back up the area here, and our whatever that is we're building back there will now get some. But that means that there's no place in the system where we are sinking the excess beams. We'll have to worry about that later. There we go. And in the process of tearing things down, I deleted one of my lifters. So we need to put that back in place. There. So this is my priority route for beams, which will fill up shortly. I did some of this build without thinking in terms of where I was going to put the overflow relief, which means you get things like this occasionally. I do have to keep my eyes open and keep verifying that everybody is moving. And we're not going to actually see this crank up again until our, well, let's, for now, what I'm going to do is I'm going to set the left to any, the right to any, and forward to overflow. So we're going to get overflow output going out this way. And I think I should do the same thing with the control rods. So currently our control rod splitters are down at that level. I'm going to raise the control rod splitters up so that it can continue onward. This is going to be a little bit janky in here. That's all right. I'm okay with a little bit of jank. So this guy is going to be any to the right and any to the left and overflow out the front. So he's going to head off to a sink. And I will need to put in some lifters to feed this guy. Should be here. I can't put this in with this guy present. And there. Every time I take a pass through the facility, I'm finding one or two little things like this that need fixing. So we won't introduce any radioactivity until I can make a pass through the factory and see everything working and not have to fix something up. And here we go from here out to, say, here. And that's my recycle. Now we need to bring the line from here. So this is my steel beam overflow. Now I'm going to step it to the left just a little bit so that I can get through the top here. And now we're going to need, oh, I could put it underneath. If I put it underneath, I'm not going to be able to escape the back. So the way I'm doing this, I haven't actually cleaned that up over there, is I take a conveyor pole. Come on, keep flying. Like that. And now we can stretch this out to here. I hadn't anticipated bringing these out like this before. We'll have to work out what to do with the overflow. But this now means that we've got steel beams going both ways until they both back up. If one of them backs up, the other one will get all of them. And when they both back up, then we'll start coming out here. Okay, so aside from syncing these two lines, I can do that later. That looks good. And that covers our belt inputs coming in here. Oh, I can actually make sure that we have completely deleted the sink area that was being used for these steel beams. The reason why I do this is this means that I can remove from my build things I don't need, and if all of these go away, then I know that I can repurpose this box area. So the other input, if I can pop the stack 4 or 5 times, we have sulfuric acid and nitric acid coming in here. And these are being piped over from a little prep area. It's actually laid out as a separate quadrant, but it was so very small. Looks like this. So we have drones that are flying in our packaged nitrogen. So this is nitrogen gas in aluminum canisters. And we bring it in and we unpackage it. So we strip it out of the package and we release the gas into the factory, and we send an empty fluid tank back out. And we are being fed by one relevant port on the other side, which is almost 3 kilometers away. It's actually way off in the distance that way, slightly west of north. Fortunately, we don't need a lot of nitrogen, but we have our 3 nitrogen stations. Each one has its own dedicated unpackage and send this back, because there's a closed loop of the empty nitrogen gas canisters. So we get full ones in, we turn around, we send the empty ones back. The drone that takes it back drops it in the other station and picks up more nitrogen and comes back here. These drones will continue to go back and forth even if they have no cargo, because neither side will ever be completely full. I could add canisters so that in the long run the drones would either be waiting to drop empties off, or they would be waiting to drop full ones off. Now, if they're waiting to drop empties, I would need to go through and prove to myself that we don't have a situation where the drone is waiting to drop off empties and the factory itself has no nitrogen. I think it's better just to let the drones go back and forth and back and forth. So you notice he didn't actually drop any cargo, because right now all of our nitrogen bottles are either here in stock or inside this loop where we've got 100 in the unpackager, and we got a bunch on the belt. So all of our nitrogen flasks are full, and they're over here, and they're waiting to be emptied. And the nitrogen comes out here. We have sulfur coming up from below. The nitrogen goes into a blender, which takes water and iron plate and turns out nitric acid. We see that that's backed up. And the sulfur heads into a refinery where we mix sulfur and water to get sulfuric acid, and also that's backed up. I have elected to merge all of these on a higher pipe level and then have an inverse U-bend to a slightly higher level. It heads out this way so that I'm trying, possibly unsuccessfully, to reduce slosh. Now, I don't think our inputs slosh at all, but I wanted this U-bend here so that any drains we got going on here don't slosh back and forth. And those are probably all useless because we have one Hongus U-bend. I'm pumping it up to this level, which might be higher than the head lift of the preparation units, the blenders and the refineries. Anyway, it pumps up to this level and does this huge long traverse where it's then provided to these blenders from above. As a general rule, I have seen a lot of evidence that you want to feed your machinery. If you've got liquids coming in, you want it fed from above. If these are all fed from level, then when one of them drains, it can actually draw liquids from the other ones, which would interfere with your full bore operation, and it causes the liquid to go back and forth in the pipe, and you end up with all sorts of weirdness. So if you do it from the top like this, then the machines only fill from the pipe. And one machine suddenly filling from the pipe, and another machine suddenly filling from the pipe, that just happens as long as we've got enough input coming down the pipe. And that works for both of these. The rules are different for gases. So that brief run over there where we've got the gas going has different rules, but these are normal liquids. So that covers our liquid runs. I haven't finished painting my recycled water. I like to tint the pipes and buffers being used for recycled water, just so I can track down through where my priorities are, and I can see that yes, this is full from coming in from the side, and when the reactor starts drawing from it, it will start drawing the recycled water in by preference once we have recycled water. And thank you, autosave. It's taking you longer and longer and longer to save in this save, but I appreciate you anyway. So let's get our sky view again. So, nuclear array, that is hopefully 180 gigawatts of electrical energy, which is the most electricity you can get out of a normal uranium mine. You notice I have a marker there for uranium in cave. That's where I'm pulling it from. I've got a uranium node, a normal uranium node in a cave off that way. And once I light that thing up, we are going to be taking all the uranium that miner on that node can give us, and it will be running through machines we have not placed in this area to produce uranium fuel rods, which will then be distributed here. So my next bit of work, now that I've got all this hooked up, aside from going back and looking at it repeatedly and fixing bugs, is to work on the underside here, where we have 30 of these holes. And what I want is to take these columns of reactors, there's 6 of them, so I want to do a splitter. I wish I had more light down here. I want to do a splitter that evenly splits the inputs across 3 of them, and we'll get 2 of those, and then we'll evenly split between the 2 of them, and that will be 1 column. And that column will come from machinery up here. The alternative is I could actually do it as 10 groups of 3. So I could evenly split these 3 and drag up the line so we end up with 10 belts, which are going to quickly move a very low rate of fuel coming through. That might be best. And that ends up with, let me bring that up to, let's see if I can show this on the screen. I'm trying to get my editor sized properly before I turn it on. There we go. So this is for 1/5. So if I went to 1/10, it would be one manufacturer building a fuel unit and one manufacturer building a infused uranium cell. There are a total of 7 distinct inputs. You see 8 consumes. One of them is the uranium cell going from the second manufacturer back into the first. So I could do a blueprint for this, which has 1 each, make 10 copies of that, and that turns out the 10 belts of fuel rods, which will then go to my reactors. Editor off. And that's what will go up in here. In the interest of maintaining my radioactivity in a smaller area, the reactors, all of the stuff, belts running to the reactors and from the reactors, those are all carrying radioactive stuff. All these machines handle radioactive stuff. These belts coming in this way, these long runs of these belts, the long belts are not radioactive, but the short ones certainly are. But to keep things tight, I will also want to do it up here. So we will end up with 2 by 5 of this size. So 2 of these high by 5 of these wide, which will be preparing uranium fuel. And each one of those has 120 uranium coming in. So 5 of those, so stripe the belts this way, you do 5 of them, and that's 600 per minute. That is doable with 1 belt. And that 1 belt would be fed by 3 drone ports. I think I can place the drone ports out this way. I'm getting very close to the edge of the world here. In fact, I put my water extractors pretty close to, if I've got much further out there, I started not being able to place them. So I will have to experiment and find out where I can place my drone ports. I may end up putting the drone ports, well, I don't want to put big, long, radioactive belts coming all the way across the world. That's bad. The other alternative is that I can take these groups of 3, merge them, and end up with 5 belts coming this way and 5 belts coming this way, or maybe 10 belts coming dead set down the middle, and do my fuel out here. And that would take up 10 of the, that actually, it's not a bad idea. So start about here and just take up 10 of these deck areas. And then put the uranium over on this side, just truck the uranium in and bada boom, here we go. I will place the uranium, there will be 6 drone ports providing uranium. We will merge them, 3 to 1, so we end up with 2 big belts. Each big belt will feed 5 of the blueprints that are creating fuel. I will have to do 1 to 5 splitters. So really what we have is a 3 to 5 split. I want to do a perfect split rather than anything that uses back pressure on one limb to go the other way. So I'll work it out. So the 3 to 5, it may be a trick. I may do something fancy, or I might just merge it down to 1 belt and split it back out. We have a 1 to 5 splitter already in our blueprint area we can use. So yeah, it sounds like the other downside is if I put my fuel down here, I have to take all of those belts that are way up there and I have to turn them around to bring them all the way down and bring it back across and down in. I can do that. Let's see, yes, I put the pipes high enough that I can still do that easily. These guys, I'm going to put this back in. Oh, I need to put this half of the foundation over. Okay. That's not hard. So we are going to do a half foundation here. We're going to zoop it. I'm going to put another half foundation here. And now we can put full foundations on again, I think. Yes. Not perfect, but good enough. And it is clear of the blenders. And I really should, well, if I were to put in vertical holes in the foundations, it would look better. It doesn't change the fluid dynamics. We can just send the pipe right through the foundation without any problem. Yeah, let's not. I only really need the foundations where I have those vertical clips that are providing support. So let's stop the foundations somewhere around here. Yep, that's right at the edge of the reactors. So that shows that we have space in here to put our 7 belts going east-west. So we can bring our 7 belts in and make the turn and feed into our fuel rod preparation area, which I'm going to keep tight down in this quadrant here. It's a complete change on how I wanted to organize, but it does keep the radioactive stuff all kind of compressed in here. I don't think I would actually want to reduce the waste handling. This keeps all of the belt runs for the waste minimum size. So by minimizing the belt length, we end up with the machines kind of stretched out like this. I don't mind it. I really don't. Now for these guys, I was talking about placing them in blueprints and putting them on the below deck, but I think, again, I'm going to rethink this, and I'm going to place them out here so it'll look something like this guy. Well, actually, let's turn it. So we'll end up with somebody producing rods and maybe back to back like this. So we have that. And I will mess around with this and get the alignment perfect, but I will have 3 ingredients coming in here and 4 ingredients coming in here, and our output from there will go under the deck to be sent off to the reactors. So that's it. I will start a new recording when we start actually evaluating the build once I've got things laid out.